Okay, so let's check this out. This is the last section of the analytical geometry chapter in this course, and we're going to be going over the distance between a point and a line. So as you can imagine, I'm just going to draw this up here. As you can imagine, if there's a point here and you want to know the distance between this point and this line, the shortest distance between this point and this line is straight across at 90 degrees. You can draw these lines and see that that line here is going to be the shortest distance between a point and a line. So that's why we've drawn here the point, the line, and that the shortest distance is going to be a right angle. So let's fill this stuff in. The shortest distance from point P to a line is the shortest distance from point P to a line is the line perpendicular. Then we have, to calculate the distance between the 2 points, we use, well, here's the thing. In order to calculate the distance between this point, where this line meets this imaginary line that would be perpendicular, we need to use the length formula, right? The big square root. The length formula, or the distance formula. And this formula requires that we have 2 points. 2 points. And we are given the coordinates of this point, but we won't be given the coordinates of this point. We have to find it. But we can, because we know that this line we will be given, the equation of this line, and we can find the equation of this line because we can find the equation of any line if we have a point that it goes through, which we do, and the slope of the line. And we know the slope of this line because these lines are perpendicular. Whatever this slope is, the negative reciprocal will be this slope. And then we have a point and a slope, and we can find the equation of this line. So point A is the intersection of the 2 perpendicular lines. And to find the point of intersection, we must solve the system of 2 equations using elimination or substitution. So in other words, we're going to find the equation of this perpendicular line. Then we're going to take that equation, solve the system, and get that intersecting point. And then we're going to use the distance or length formula with these 2 points to find the length of that distance. So let's do some together. First, find an equation for a line that is perpendicular to the line of this and passes through this point, right? So passes through this point and is perpendicular to that. So we can do this, no problem. We know that we need a point, we have it. We need a slope, we can find it. So what's the slope of this line? And then let's do the negative reciprocal, and it'll tell us the slope of the line that we want. Well, first we have to put this in y equals mx plus b. So now we have y equals 4 over 3x minus 7 over 3. So our slope of this line is that. So therefore the slope of a line perpendicular will be negative flip. So there's our slope, here's our point, and now we will find the equation. So I'm going to show you the 2 ways. There are really 2 ways you can do this. And previously I've done this, so I'll just do it again, and then I'll show you the other way. Y equals mx plus b. We know y is 2. We know m is negative 3 over 4. And we know x is negative 5. And b is the only unknown. So there we go. We will solve for b. So we've got 2 equals, and this is positive 15 over 4. So we've got 2 minus 15 over 4 when we bring it over the equal sign. And if we're going to find a common denominator, we multiply the bottom by 4. We have to multiply the top by 4. And 8 minus 15 is 7 over 4. Oops, negative 7 over 4. So write an equation for the line that's perpendicular to that and goes through that point. Therefore, the equation of the line is y equals, our slope was negative 3 over 4, and our y-intercept is 7. Let me show you how you can also solve this using the point slope instead of slope intercept. So I'm just going to use this paper here. So here if we are given this is the slope, which is negative 3 over 4, and the point is negative 5, 2. You can plug it into point slope, which is y minus y1 equals m, x minus x1. You plug in the slope, you plug in the point, so x is negative 5, so minus minus 5, and y is 2. And then you just simplify this. You can put it into y equals mx plus b, or you can put it into standard form. So what we would do is we would first multiply this out, so y minus 2 equals negative 3 over 4x minus 15 over 4. Then you get rid of the fraction, so you multiply by the lowest common denominator, which is 4. So we multiply that by 4, that by 4, that by 4, and that by 4. And then we bring everything over here and put it in order, our x, our y, and then our constants equals 0, and then we check this as positive. It is. We check there's no fractions there, aren't, and then we just simplify this. 3x plus 4y plus 7 equals 0, or we could put it into, we could rearrange this into y equals mx plus b. Certainly we would do 4y equals negative 3x minus 7. Divide both sides by 4. And as you can see, that is what we had here. It's the same thing. It all takes you to the same place. Whether you do point slope, here, point slope to find the equation, or whether you do plug into y equals mx plus b. It's up to you. Okay, so let's do more of this distance from a point to a line. So I'm going to give you this question. I want you to do it, and then we're going to take it up. Find the exact value, whatever, that just means plug it into a calculator, of the shortest distance from this point to this line. So the point is 5, negative 2, and the line is 4x plus 3y plus 14 equals 0. Go.